Okay, in this section, we're going to talk about parametric equations, which is really just another way to represent the equations of curves. In this case, we have x and y that are given in terms of a third variable, t in this case. It's called the parameter. So you can think of t as being the time at which an object is at these coordinates. Anyway, if you were to plot this or graph this curve, you don't usually graph the t. The t will determine the value of x and y. So for example, when t is negative 1, you know that x is negative 2, and when you plug in negative 1 for y, I think you get 0. So for every value of t, you can figure out what x and y are. And the interesting thing about this is not only do you get the graph, but you also get the direction at which the curve is traversed. So for example, at t equals 0, t equal negative 1. At t equal negative 1, you start off at the point negative 2, 0. Remember, this is x and y. At t equals 0, you're at the point negative 1, 3. At t equal 1, you're at the point 0, 4. And at t equal 2, you're at the point 1, 3. So the curve is traversed from left to right in this case. Oftentimes, but not always, you can eliminate the parameter t. One way to do it is to actually solve the equation, solve one of the equations for t. The first one, if you solve for t, you get t equals x plus 1. And then wherever there's a t in the second equation, you can plug in x plus 1 like this, and you end up getting y equals 4 minus x squared. So these parametric equations define a piece of this equation, y equals 4 minus x squared. Let's try another one. Suppose we have this one, x equals negative t, y equals 4 minus t squared. Alright, so in this case, let's see, we're going to pick some values of t, like when t is negative 1, you see that if t is negative 1, you plug in for x becomes positive 1, and when you plug negative 1 in for t for y, you get 3. So you get the point 1, 3 when t equals negative 1. So then you pick some more t values, and when you plot them, no, at t equal negative 1, you're at the point 1, 3. So you start off over here at 1, 3, and then at t equals 0, you're at 0, 4. At t equal 1, you're at negative 1, 3. And at t equal 2, you're at negative 2, 0. So in this case, the curve is traversed from right to left. There might be times when you want to do that. If you eliminate the parameter, it turns out you get the same equation we got before. Even though the curves that we got were different because they were traversed in a different order, but when you eliminate the parameter t, you would solve this equation for t and you plug it in to y. T would be negative x, so you get y equals 4 minus negative x squared, or 4 minus x squared. You get the same. X equals e to the t, y equals 4 minus e to the 2t. So if you were to make a table of some values of t, when t is negative 1, you'd get x would be e to the t, which is 1 over, x would be e to the negative 1, which is 1 over e. And if you plug negative 1 in here, you get 4 minus e to the negative 2, which is about 3.9. I approximated this. So if you continue to plug these values of t in for x and y, you get these points. And when you plot them, you get something that looks like this. Now, this curve here, when t equals negative 1, you start at the point 1 over e, about 3.9, and as you pick these, as t increases, notice you get these points on the curve. So this is what you would get. This last one's so low I couldn't even fit it on here. Anyway, when you eliminate the parameter, look what happens. You wherever there's, think of 4 minus e to the 2t as 4 minus e to the t squared, so that's what x is, right? So it's just 4 minus x squared. Again, we got the same equation back in each case, but really the graph that was sketched is actually different in each one, isn't it? Let's try something different. How about this one? X equals cosine t, y equals sine t. You've actually seen this before in your pre-calculus course for t between 0 and 2 pi. And so if you want to sketch the curve, remember you're picking some values of t, and you plug them in for x and y. When t equals 0, we're in radians here, by the way. Cosine of 0 is 1, sine of 0 is 0, so you get the point 1, 0. If you were to pick some more points, I didn't pick every single point, but I'm just picking like the pi over 4s, you know. You could get these points, for example, at pi over 4, the cosine of pi over 4 is radical 2 over 2, and so is the sine, radical 2 over 2. If you were to plot these, you start off when t equals 0, you start off at 1, 0, and notice that as you move around, you're moving around counterclockwise. We use this particular parameterization when we define the trig functions. in Math 142, but we didn't call them parametric equations, but that's what they were. Now when you eliminate the parameter, we're going to use the fact that cosine squared plus sine squared is 1. Remember, x is cosine t and y is sine t. So you can plug in here x for cosine and y for sine, and lo and behold, you get the unit circle, which shouldn't be too surprising. It's not just the unit circle, it's the unit circle starting at 1, 0, and it's traversed counterclockwise. Alright, let's continue. Now, in this one, what I did was I switched them. Instead of saying x equals cosine t, I'm saying x is sine t, and y is cosine t. So let's see how it's different. You would start off by picking a value of t, like t equals 0, x would be 0, y would be 1. And you would continue on the same way we did before. So what's different about this curve? Well, it turns out what's different is, first of all, when t equals 0, you start off at 0, 1. You start off right here. And as t increases, if you look at these points carefully, at t equals pi over 4, you're at the point radical 2 over 2, radical 2 over 2. At t equal pi over 2, you're at 1, 0. So the curve is being traversed clockwise, starting at 0, 1. When you eliminate the parameter, you shouldn't be too surprised. You get the same equation back. So the point is, there's lots of ways to parameterize an equation. You'll have a different starting point, and you may be traversing a different direction, and you may not get all of the curve either. You may just get a part of the curve. Alright, how about you do this? See if you can, go ahead, hit the pause button, and see if you can, for this particular example, you're going to be on the unit circle again. Pick some values of t, compute x and y, and see if you can figure out where you start on the unit circle and what direction it's traversed. Okay, so you would, to graph this, you would make a table, and for t, some specific t values, you'd find x and y, right? When t equals 0, you get x would be negative 0 plus 1, or negative 0 comma 1, so 0, 1 is your point. And you should have gotten a unit circle where you start at 0, 1 and you move counterclockwise from there. Did you get that? We didn't do this, but if you eliminate the parameter, of course you get x squared plus y squared equals 1, don't you? Alright, well let's talk about this. Let's talk about how to use the graphing calculator here to graph these. There's kind of some nice stuff you can do here. First of all, make sure when you go to mode, make sure that you move it over to parametric mode, okay? And then if you go to y equals, it becomes x1. This would be the equation for the x and y for the first. This would be, in this case, this would be negative sine t, right? So notice every equation has two parametric equations, or I should say every graph has a pair of parametric equations. So we would hit negative sine of t. Now when you hit the x button up here, the x button, it becomes a t. Okay? That just does it automatically. And so for the second equation, we're going to hit cosine t. Okay, got that right. Now, before we graph, if we go to window, we're going to give it the t value. I'm going to go t0 to 2 pi. If it isn't on 2 pi, all you have to do would be to hit 2. And then if you hit the pi button, which is over here, you'd hit second and then pi. That'll give you the pi. Now the t-step is really important because this t-step here, it can slow down the graph. Let's go to 0.4 for now, for t-step. Since we're graphing the unit circle, it might be good to have x go from... now, it's only going to graph the x values. Remember, it doesn't graph t. So x goes from negative 2 to 2, and y goes from negative 2 to 2. That would be a pretty good window. So when you graph this, sure enough, you get the unit circle. Let me slow it down a little bit, though. That was a little too fast. Instead of saying t-step equal 0.4, if you change it to like 0.1, for example, and you graph it, notice it slows it down. You can actually see it better. It's a little too fast still. How about 0.05? Let's try that. So at t equals 0, we're up here, and then we move around the unit circle that way. So that's kind of nice, because that way you can see the direction easier. This last thing I want to do is kind of fun. In this case, some homework problems like this, I thought we should look at a couple. I'm giving you the graphs of the parametric equations for x and y. Suppose x equals f of t and y equals g of t. I want you to be able to tell me what would the actual equation y as a function of x look like if you were to graph y as, in terms of x. And here's how I look at it. Notice at t equals, notice both of these are defined for t between 0 and 2. Do you see that? This is the t-axis. This is the x-axis. This is the t-axis here. This is the y-axis. So it's only defined between t equals 0 and 2. At t equals 0, x is 2 and y is negative 1. So you have the point 2, negative 1. That's that point right there. If t equals 1, x is 1 and y is 0. So you'd have this point, 1, 0. At t equal 2, x is 2 and y is 1. So you have the point 2, 1. So the graph, you have this point, this point, and this point, and obviously it's traversed in this direction. In terms of what does the actual graph look like? Is it a V shape? Is it a U shape? This is like a qualitative example. So either just have it so that it looks kind of like that. Let's not worry about how steep it is at this point. Okay, why don't you try one? See if you can do this one. See if you can hit the pause button and see what the graph y as a function of x would look like. Okay, in this one, notice x and y. This is t. This is x. This is t. This is y. This is defined t is between negative 1 and 1 in both cases, right? Okay. So what about when t is negative 1? It looks like when t is negative 1, x is negative 1, and y is 0, right? Negative 1, 0, right here. When t is 0, x is 0, y is 1. So plot the point negative 1, 0, plot the point 0, 1. And when t is 1, x is 1 and y is 0. So you plot this point and then just draw the line. Okay, let's do one more. This one's kind of hard. Here, the graph is defined for t from negative infinity to infinity. Okay, so let's just focus. Let's just look over here, for example. If t is a negative number, okay, let's say t is a negative number. Isn't x going to be very negative? Remember, this is t, this is x. X would be a very negative number, and so if t is a negative number, x would be very negative and y would be very negative. So it would be down here somewhere, let's say. As t gets close to negative 1, x is getting close to 0, right? And y is getting close to negative 1. All right, so x is getting close to 0. I'm sorry, as t is getting close to negative 1, both x and y are getting close to 0. That's better. So we're getting close to this point 0, 0. Now if t is getting close to 0, x is getting close to 0, y is getting close to 1. Notice, x goes up to about a half but comes back to 0. So the x-coordinate should be getting close to 1/2 and come back to 0. The y-coordinate, though, is getting close to 1. So that's why it has a little loop here. Now, if x is between, I should say t, if t is between 0 and 1, then the x value is going to be negative, but it goes down to about a half, negative a half, and comes back to 0. The y-coordinate, however, is going from 1 to 0. So from t equal 0 to 1, the x-coordinate is going to negative 1/2 and coming back to 0, and the y-coordinate is going from 1 to 0. So it has this little loop here. And then if t is bigger than 1, notice the x-coordinate is becoming very, very large, but the y-coordinate is becoming very negative. So this is why the graph goes down like that. Pretty fun, huh? Alrighty, we'll see you next time. Bye-bye.